Okay, so yeah, I have audio. I just muted my mic.
Seems to be okay.
Seems so.
Just waiting on that live notification. Aaron?
Yeah. Oh, there we go. Hello, guys. Welcome to Total Space Network. I'm AnotherSpaceNut, and today we've got a special guests from Nexus Aurora. I'm going to pass over to the next host of this show, and then we'll do a round of guest introductions.
Hi, I'm Rich LB, co-host on Becoming Multiplanetary. I'm here for this TSN special with the Nexus Aurora folks, and I will pass over to Adrian to introduce himself.
Hi, I'm Adrian, also known as Space Instructor. I'm the founder of Nexus Aurora, and together with the team, we've been working very hard at creating a Mars colony proposal, which recently won the first prize at the Mars Society City-State Design Competition. I'll pass the microphone to Koen.
Thank you, Adrian. My name is Koen Cohen, also known as Next Astro. Together with Adrian and a lot of the people that you see here today, we worked hard on the Mars City-State Design Competition, which we won. And currently, I'm working on a lot of different projects, amongst others, a YouTube channel about human spaceflight called Next Astro.
I'm Sam. I don't have no other names as far as I'm aware. I was one of the lead authors on the original Nexus Aurora report. I'm also a mechanical engineering student. I'm working currently on autonomous farming robots and many other things.
I am Ilho, and I was one of the people who was working as a domain lead on the Nexus Aurora report, as well as working on the Singapore Moon Rover Challenge as one of the participants. Most of my work has to do with the mechanical aspects of extraterrestrial robotics, and after this is over, I'm also currently heading up the core lead of the ESS spacesuits.
I'm Julian. I'm also part of the core team of Nexus Aurora from the beginning. There I was mostly working on the production of petrochemicals without having actual petrochemistry, without having oil. And since then, I've joined the EHRI, Extraterrestrial Habitation Research Institute, where I am currently leading a project on studying the effect of microgravity on human immune cells, mostly T cells, for which we plan to build a CubeSat.
I'm Orion Lawler. I live in Alaska, and that gave me the ability when we started with Nexus Aurora to run some little experiments, so little backyard playing around with stuff. So that's kind of been my role for the Extraterrestrial Habitation Research Institute.
So you're here to talk a little bit more with us today, guys. I will let you do the talking. This is your show, your opportunity.
In that case, I feel maybe Adrian should kick off with how Nexus Aurora came to be. Maybe that's a good way to start it off.
Yeah, absolutely. That's definitely a nice story. So we got together on Reddit mostly. Back then, like 9 months ago, I was looking to join forces with Mars or Bust, Dave, the YouTuber. So we were discussing about potentially creating some interesting materials together, but eventually we learned about the Mars Society competition, the City-State Design Competition. And since then, I've been running all over the social media, making as much as possible noise about Nexus Aurora and this great project. It was a rush to see all these people joining. I think one of the most exhilarating moments was just to see all these introductions from various aerospace engineers, scientists, physicists, and all sorts of other people, such as like architects and so on. So it's quite an interesting community. The cool part is that even after winning the contest, we're still together. So For a while, we were like soul searching, trying to figure out where we are going, but it looks like we found a way to keep the team together while also having multiple objectives. So today we have 3 topics on the table. We have like the next Aurora report, which was created in this period of quarantine during the COVID crisis. So we had the opportunity to use our brains and create something really smart. After this, a few other ideas have emerged, and one of them is this research project where I've seen so many interesting projects. They tried all sorts of stuff, such as like Marscrete and many other things. They experimented, and I think that will be better left to Orion and Julian to talk about. And also, I think it's really interesting to discuss about the Moon Rover, which is Ilho's project. So I was quite impressed to see an engineering project going into the details of where like the sprockets and nuts and bolts of everything goes. So I think it's quite an interesting story. And now we are also trying to grow a bit by going on YouTube. We are trying to use all sorts of social media. So I think an important thing to remember is that we are on open team, and whether you are like young or old, you have a place there. So feel free to join. How about you, Kun?
Well, yeah, I would say the strength of the whole team is that we started open and we stayed open. And what originated from winning also the Mars City State design competition is that we now have dozens of Discord servers that are also connected to what we call a global aerospace innovation network or space ventures that we have grown into with Nexus Aurora, because there are so many different projects that people are interested in from all around the world that it was too much for one server. And as you will hear during this talk today, a lot of people have their own very specific interest. And what I really like is that it's sort of an evolutionary thing. Some of these servers die if there's not enough interest and activity, and a lot of them survive and produce great content. And as you hear today, of course, from Ilo and other people, and also Sam and Julian and Orion, there are like dozens of those servers, and one better than the other. And one that I'm working on personally most is at this moment not only the Next Astro server, but also Beyond Earth architecture, which is sort of a continuation of the idea of creating architecture on Mars, but also general rules for surviving in space. Focus is currently on orbital stations that we can shoot in a single launch on, for example, a Starship rocket. And with that, I think it might be good to, I would say maybe M5D by Sam is a good way to talk, to continue.
Yeah, I'll give that a brief introduction. N5D is our project that we have to sort of keep all of our industry in one place, which has a very broad kind of focus. It's got stuff about mining, water extraction, atmospheric purification, chemical engineering, farming, sort of the whole spectrum. And it's about getting into drilling down to serious engineering and actually trying to build things that can be built in the next 2 or 3 years to do these jobs on Earth, and then hopefully sort of provide trailblazers to then actually be sent out into space. The current live project there is a collaboration with a few of us. With the Mars Society, run the MDRS Desert Research Station in Utah, which they very kindly let us bid for some projects to be sent up in November or December. I can't remember exactly when their shipping deadline is. So we're pitching 4 different proposals. My personal project, autonomous farming. We've got one on dust removal from spacesuits, one on thermal electric generators, and one that I've completely forgotten, which is very bad of me. One on scouting robotics and autonomous sort of survey bots. So we're getting into the real practical hard mechanical engineering, software engineering, electronic integration to actually build these robots, build these pieces of hardware, and send them out to very Mars-like environments around the world. And I can actually segue from that quite neatly into the actual report, if you like, just to talk a bit more about the Nexus Aurora 20-pager that we did. So one of the strengths that I feel we really had going into this competition, and one of the strengths that we played to as best we could, was that we're not really the experts on this. We're all hobbyists or students or people who've got sort of adjacent careers in architecture or mechanical engineering. None of us are in any way formally trained in aerospace or space engineering. So what we provide in a way that no one else really has is an outsider fresh look. And we can say, great, you have this established doctrine about how you go to space. Is that actually the best? Have you thought this through? Have you run it through with modern understanding? You want to land in the northern hemisphere of Mars. Is that the best these days with these current thinking? And because we're not sort of indoctrinated, we can go back and challenge that doctrine. And that was, I feel, one of our really big strengths, something that really played to our advantage in the Mars report, is saying, what can we present that is completely new and completely sort of revolutionary rather than evolutionary on old ideas? How can we say we don't want to try and do chemical synthesis from pure electrochemistry from the atmosphere? Can we use biological starting routes? And that's what Julian's project was, which is, I think, a remarkable sort of high point for the community, is this huge amount of what do you guys call it? Biopetrochemical industry? Or how can we do architecture better? How can we go back to the drawing board about the fundamental laws of architecture and physics on Mars and say, what is the best way of building a building on Mars? And that sort of spirit in the community has carried us all the way through. We're still saying, you have these ideas about how to build a space station or how to build a spacesuit or how to go about building a space, an OS for space, operating system for space, spacecraft control. Is that really the best approach? Can we do better as a community that has an outsider perspective, a lot of very diverse experience, and then in some cases we can't, I'll freely admit, but in some cases, as the Master Society judges clearly thought, we can produce something quite valuable and provide some really useful insight.
And may I ask, what was, for example, from your point of view, most interesting aspect of this process of trying to crowdsource the project?
It was really a learning experience for me, because I'm a university student. I'm not some expert speaking from on high as anyone else is, but it was remarkable having people come in and say, oh, here is this one little nugget that I know very well. Here is this little biochemistry thing. Here is this little architectural thing. And taking that and then combining this all together. And you'd never have got that if it hadn't been such a big and open community, because you'd have said, oh, you're an architect on Earth. You don't have an opinion on this. You don't know how these things work. We're going to leave it to the aerospace engineers only. And we said, no, your opinion is completely as valid as ours. You're no more an expert than I am. What can you bring to the table? And that was a great experience for me, because it means that I now can have a conversation with the architects in my course and say, oh, well, actually, have you thought about it this way? And it's a great community to be in where that sort of is the norm and where knowledge just gets chucked around.
So, Ehri, can you describe a bit this Moon Rover project you are working on?
Sure, but to start describing the moon, I actually have to go back to the 20 pager. So, during the 20 pager, what happened? We developed a logistics system. We needed vehicles. We needed a very general purpose vehicle that could do everything. It didn't have to be the best at everything, but it had to be able to do everything well enough. And so we came up with what's known as the space tractor concept. And yes, it is exactly as uncreative as it sounds. It is taking an electric tractor from Earth and throwing it on another planet and making it pretty easily repairable and very, very, very versatile. What happened during the Moon Rover project is that the Singapore Space Technology Limited came out with the every year they come out and they do the Singapore Space Challenge, and during that challenge this year it was design a moon rover that was capable of doing excavation and in-situ resource utilization. Now, made everyone aware of it. And so we assembled a small team that this thing worked. One of the requirements was the fact that we needed to do excavation or in-situ resource utilization. Our team managed to do both and then go a level beyond that. by taking the space tractor concept and sort of miniaturizing it down to something like a space bobcat. And it was actually really interesting because doing the FEA, doing all of this, a lot of things that would normally, even on such a small rover, it was, I think the dimensions of the entire mission had to fit within a 1 meter by 1 meter by 1 meter package and weigh no more than 60 kilograms. Now, we sort of got that goal. We discovered an error later on, but that's besides the point, but that'll be explained later. What happened was we said, okay, so what do we need? Well, we have to do a whole bunch of things. You know, we need to land. We need to go and dig out stuff. We need to actually use it for something useful. We need to process it. We have to study how to process it. So and in order to do that, we went through a lot of experimentation, specifically on my end and on Orion's end, because he helped us out with this too. We went and we essentially threw a whole bunch of regolith at a bunch of other stuff, basalt, dust, whatever. We hit it with an electric arc, put it in a hydraulic press, fired it up in an induction furnace, and we decided that, okay, the induction furnace method works. We need kilo power. How do we solve that? How do we solve this? How do we solve that? And it just went back and forth and back and forth and back and forth. And there's quite a bit of things that went at, but eventually, when all was said and done, we decided that, you know what, this rover, it has a problem with heat dissipation because it needs so much power in such a small package, and there's no way to radiate it out. So we decided to take a very interesting route. We cut away all the thermal insulation on it, which sounds like a terrible idea. But it made sense because we had to radiate, because that meant all the heat now we'll bury it under the ground, we'll store everything during the night, and we'll let it go the next day. And really, we ended up with more of a base building concept than an actual exploration rover. And I think that's actually pretty relevant because we're going to have to industrialize resources later on, and the system is expandable. One of my favorite parts about the project was getting into the literal nuts and bolts of the design. You know, how do we make this rover able to use tools? It has to be able to pick up the tools by itself. It has to be able to move around by itself. It has to be able to, you know, hit a rock with a knife by itself. And these tools can't have motors or power sources on them because they're just too heavy. So during that time, it was actually a really difficult problem to solve. And we came up with a common manipulator specification that went in and and it could do all those things. It could provide power to shafts through gears, grip the shafts, grip other tools. And eventually we managed to integrate a USB and a power contact into there so we could transfer data and power just by grabbing onto the appropriate tab. I definitely think that we needed more time. We identified a little problem with our kilo power solution later, which was to use giant reflectors and concentrator photovoltaics and then graphene radiators. But that was actually really, really fun to do because, like Sam said, it gets into the nuts and bolts of things. And it wasn't a hugely complicated project. It really forced us to think about things in a much more simplistic way and simplify them down to, okay, what do we need? How can we make it? And what is the absolute bare minimum needed in order to not only do the mission, but also expand on what we can do? It gave us a bunch of capabilities that I never realized the concept could have, and I was the one who thought of the space tractor in the first place. We can actually deploy smaller CubeSat-sized payloads. We can bring them along for, you know, a cost that's for extra mass, extra cost, and we can place them around on the lunar surface. We can power them. We can send data to them. It ended up being more versatile than I actually expected. And I think that one of the things that we're going to need in the future is that we're going to need a solution, not a perfect solution, but a very deployable solution that can be mass produced, so we can take advantage of those economies of scale that come with production rather than single use exploration missions.
Speaking of this, I might ask, do you have any plans to continue this work with this rover up to the stage of trying it in real hardware, and possibly we could use the contact from the Mars Desert Research Station and just possibly go there a bit? Is this something that you'd consider?
Actually, yes, I am considering it, but after I finish the spacesuit, because to get to this point where we're going to be able to make a full-scale space tractor, or even one that's remotely more useful than an astronaut, is going to be a while. It's going to be a fair bit of capital, even if we don't do it with space grade or space certified hardware, because, well, the actual rover, or what we call the mobile worker unit, was it's very small. I can actually sort of grab it here. It's about yay big. So it was very small. It's one of those things that it's a proof of concept that I don't think it's actually worth putting into MDRS right now, but once it's possible to get the a slightly larger scale, more capable version out there and solve some of the issues with actually having high-powered machinery, then I truly believe that it's worth it.
You can hear a lot about the culture in Nexus Aurora here by saying, oh, we'll do the Mars rover after the spacesuit's finished, because for the spacesuit to work, we have to have that work. It's the whole, that's what it's like here.
It's like everything's everywhere. It's, in Dr. Orion Lawler's words, herding 10,000 cats in a bag. And actually, I think him and Julian can probably explain that quote much better in the production side of things.
Julian, you're so muted.
Yeah, sorry. That's exactly why the EHRI, the Extraterrestrial Habitation Research Institute, was founded by us. It focuses more on the foundations, on the foundational science of what is needed for actual space production, and to tackle all of the challenges that a Mars colony, for example, would face. So during the actual project, during the Mars project, we had a problem with we had a problem that we needed to figure out how we produce, for example, medicine on Mars, because you can't rely on shipments from Earth, because if only one shipment gets lost, then the colony is without any help from the outside for a very long time due to the short launch windows. And so we thought about, okay, what processes can we use to basically build a petrochemical industry on Mars? And then we came up with ideas to use plants, because we have oil on Mars, and methods of using CO2, for example, from the atmosphere are also really tedious and not effective. And there's a lot of plant waste anyway. And so we came up with a process, entire process network that we call biopetrochemical industry. And it is basically all based on pyrolysis. And most of our projects on the EHRI that we focus on today are also resulting from this work, but there's also a few others that have come later on. But for example, we have also worked on a way to gain explosives on Mars. You need explosives for mining, and there's not a lot of nitrates on Mars, so we took to other sources that could be better investigated. And there's also a lot of other projects, as I said before, and yeah, soon we will be publishing our first journal in which we have all of those reports, and this will contain work on the percolate blasting, which was done by Orion Lawler, who can now, I think, talk a bit more about this.
Yeah, so the background here is that if you have meter-thick deposits of hard rock that you need to get out of the way, removing them mechanically is really, really expensive. So on Earth, the traditional way to do this, to get rid of rock, is to blast it. So you drill holes in it, you fill the holes with explosives, and then you blow the rock apart. This is huge in construction. If you have thick ledges of rock that you need to get out of the way, if you're doing mining, you need to extract big chunks of stuff. So it's yeah. So the problem on Mars is that there's almost no nitrogen.
Okay, so it's my end.
No, I can hear you fine.
Yeah, we can hear you.
So
okay, so it's my end. Sorry,
we're good. Yeah. Yep. Good. Yep. So we're in this weird situation where we know how to make explosives on Earth, right? They've been doing this for hundreds of years with nitrogen-based chemistry, right? So nitroglycerin was one of the oldest ones, or gunpowder, just potassium nitrate. And the problem is there's not much nitrogen on Mars, period. You need a lot of it for breathing atmosphere, right? Like the more nitrogen that you can put in the air, the happier and healthier people and plants are going to be inside. And the problem is when you use nitrogen-based explosives, the nitrogen is mostly lost. So the problem that we faced was basically how do we actually get this done? You need ton quantities of explosives to move your thousands of tons of hard rock. So we looked, well, what do we got on Mars? And it turns out there's this naturally occurring hazard, which is perchlorate salts. So so on Earth there's a lot of brines, which are chlorides. It's just one chlorine atom, and then it's got some sort of alkali on it. And on Mars, they're all oxidized all the way to perchlorate, which is a chlorine atom with 4 oxygens around it. So the perchlorates are kind of a problem because they mess up your thyroid. So you need to wash them out of the incoming regolith anyway. And the real question is, what do we do with these perchlorates? We're going to end up with tons of perchlorates, literally, and we need to do something with them. The other waste product that we have, when we do flash pyrolysis of agricultural waste, which is kind of this is one of the strategies we're considering for synthesizing petrochemicals. And it produces, like, you get this nice carbon char, you get volatiles like your BTX, your aromatic compounds, but you also get these tars, which are usually poisonous, and they're kind of just sticky mess. So the idea is you take 2 waste products, which is perchlorate and tar, and what can you do useful with them? And it turns out there's a bunch of perchlorate-based explosives. And prior to nitrogen kind of taking over the explosives industry on Earth, back in the late 1800s, there's papers on using perchlorate for explosives. So we thought, this sounds awesome. Let's use 2 waste products to actually create something useful. And we tried it out. Actually, we tried it in about 10 other compositions of things that we thought we could manufacture. And it turns out perchlorate and tars work really well for blasting. And we actually, we tried to figure out how to test this safely. We mostly haven't figured out how to test safely. If you use about 1 gram of perchlorate-based explosives, you can crack a big, like an 8 kilogram rock that's 8,000 times heavier than the amount of explosive you're using, which is kind of
Julian,
crazy.
You might want to talk a bit about the medicine part.
Yes. So the Ehri is also researching the medical aspects of space science a bit. For this, we will publish soon a review that was done by the Space Medical Tech Discord server of Aurora, which we have made a review about the use of contraceptives in space and their benefits to the astronauts. And we are also currently working on a CubeSat that will hopefully someday get launched into space, and it will then study how human immune cells, especially T cells, will react in microgravity. And this is a quite important topic to know, because for long-term gravity, there might be adverse health effects due to exposure to microgravity, because this can, for example, alter the gene expression of these cells. And to really make sure that long space flights are safe, such research has to also be done, which is quite in line with the motives of Ehri to provide research that is beneficial to spaceflight and settlement of humans on other planets. Can you guys still hear me?
So apparently
Yes,
I dropped
yes.
out briefly.
Okay, I think I dropped out for a second, so I think it's best.
Okay, Orion, would you like to
We're having
continue?
dueling network dropouts. Sure. So I was able to actually blast rock using perchlorate, so it's okay.